the radicals together. Okay, that's only if the index is the same. So if you have one that's like this, radical something times, see how the indexes are different? Then you can't even do anything with those. Like, you just have to stop, okay? If there was another one and it was like this, okay, you could put these two together, but not this one, okay? So the index has to be the same in order for you to even continue, okay? So if we look at the very number 1, are the indexes the same? Yes, they are both a 2. There's no number on the outside, so it's a 2. Okay, so that means that we can multiply the insides together. Okay, so what is 15 times 2? 30. Okay, so 15 times 2 is 30. And then you're going to go ahead and start making that tree. And what are our magic numbers?
2, 3, 5, 7.
2, 3, 5, 7. So 30 is going to be 2, 15, 3, 5. Okay, so who can go? No one can go. Okay, so if you're looking like this, so can the 2 go?
No.
No, so where's he going to go?
Inside.
Back on the inside. Can the 3 go?
No.
No, he's going to go back on the inside. Can the 5 go?
No.
No, he's going to go back on the inside. Do we do anything with the 15? No, remember? 2, 3, 5, 7. Okay, well, what do you do with all the numbers if they're back on the inside? You multiply them. So 2 times 3 times 5 is still 30. Okay, what this is saying is that in this case, the radical cannot be simplified. Okay? Okay, but that just so happens to be a fluke because most of them can simplify. Okay, so make sure that you're checking them. Okay, so number 3, are the indexes the same? Yeah, so it means we can multiply the insides together. Okay, so 10 times 5 is 50. And then 50 is going to be 2, 25, 5, 5. Okay, so who can go?
2, 5.
2 5s can go. Who cannot go?
2.
The 2. Isaiah, put your phone up, please. Thank you. Okay, 5. Are the indexes the same? Yeah, so we can multiply the insides together. So 8 times 10
240.
is 80.
Oh, no.
Oh, shoot, I about wrote 242. I was looking at 2. 80. Oh, 2 and 40. I got you. Okay, so 240, 220, 210, 25. Okay, so who can go?
2.
2 groups of 2. So how many 2's are going to be on the outside?
2.
2. Okay, 1 for each group. Okay, so 2, 2, and a 5 goes back on the inside. What do you do with that 2, 2?
Multiply.
Multiply. So 2 times 2? It's going to be 4 square root 5. Okay, 7. Are the indexes the same? Yeah, so 6 times 8
48.
is 48. Okay, so it's going to be 224, 212, 26, 23. Okay, so 2 groups of 2's can go. So what number is going to be on the outside?
2.
A 4, right? So 2 times 2 is going to be 4 square root 3. Okay, number 9. Are the indexes the same? Yeah, so 10 times 15?
150.
150. 150? 275? 275, or 75? 3 and 25? 5, 5. Did I do that right?
Yeah.
Okay. Okay, so who can go? The 5 and 5. Who cannot go? the 2 and 3. So it's going to look like 5 square root 6. Okay, number 11. Okay, are the indexes the same? Yeah, so 9 times 3 is going to be 27. And then you got 3, 9, 3, 3. Okay, so a group of 3s can go. Who can't go? A 3. So it's going to look like 3 square root 3. Okay, 6 times 15. Huh? 990?
Just 90.
Just 90? Is that right? 6 times 15? Okay. 90. 245. 45.
215.
315. 35. Okay, who can go?
3.
A group of 3s. Who can't go?
2.
2 and 5, so it's going to be 3 square root 10. Okay, so I'm going to do 15, and it's the longer-ish way, and then hopefully you can like figure out the shortcut. Okay? Are the indexes the same? Yes. Okay, 20 times 20,
400.
400. Okay, so 400 is going to be 2 and 200, 2 and 100, 2 and 50, 2 and 25, 5 and 5. Okay, who can go?
2.
2.
Okay, so who's going to be left on the inside?
No one.
Nobody. Okay, and then 2 times 2 times 5
20.
is 20. Okay, what do you notice from what you started with to what you ended with?
It went on the outside.
It just went on the outside and the square root disappeared. Okay, but only one of the numbers went on the outside. So what is really happening with square roots is, and don't write over here, but, so it looks like this. Okay, well, 20 squared, or 20 times 20, is really 20 times 20, or, okay, and so it's really 20 squared. Okay, and so what happens is this 2 cancels this 2 out, and it also cancels the house, and so you're left with whatever's on the inside. Okay, and so that's like the long drawn out way of how square roots work. So if your indexes are the same and you have 2 of the same numbers on the inside, you're going to end up with the exact same number on the outside. So if you have a problem like this, square root of 9 times square root of 9, what is my final answer going to be?
9.
Just 9 with no square root. Okay? And the same works if we have square root of 2 times square root of 2, okay? It's going to be square root of 4, which is 2 and 2, so that means 1 can go. Okay, so you're left with just 1 on the outside. It works every single time. So if you have 2 numbers on the inside, you're just going to have 1 number left on the outside, and I just erased part of the wrong stuff, so. So this is just 20. Okay, 17, 2 times 5 is going to be 10. 10 is going to be 2 5, so who can go? Huh? Nobody can go, so then where do we put them?
Inside.
Back on the inside, and then do what with them? Multiply them, and what is that going to give you? The thing, same thing, so square root of 10, okay? All that means is it didn't simplify, okay? And last one, 6 times 2,
12.
it's gonna be 12. It's gonna be 2, 6, 2, 3. Okay, you guys have 10 to do on your own. Go through and get your 10 done.